Hey there folks, John Oliver here, and today we're diving into the world of cryptography. Think of cryptography like sending secret messages. Imagine you're a kid again passing notes in class. You don't want the teacher, or that annoying know-it-all Timmy, to read your message, right? So, you and your friend come up with a secret code that only you two understand. In the digital world, cryptography is used to protect your information from unauthorized access. It's the digital equivalent of a secret handshake, ensuring that only the right people can access your information. Let's break down how this whole cryptography thing actually works, shall we? The first step is encryption. This is where we turn your plain, easy-to-understand message into something that looks like gibberish to anyone who's not supposed to see it. Imagine you're writing a postcard to your grandma, telling her you'll be visiting next week. You decide to use a simple code. Each letter in your message will be replaced by the letter that comes after it in the alphabet. So, grandma becomes HSBinfo, cookies become DPPLJF, and so on. Of course, the encryption methods used in the real world are far more complex than our simple alphabet swap. Now, what good is a secret message if the recipient can't read it? That's where decryption comes in. It's the process of reversing the encryption process, taking that jumbled mess of data and turning it back into your original message. Remember our postcard example? Your grandma, being the clever cookie enthusiast she is, knows the code you used. So, she simply shifts each letter in your message back one space in the alphabet to reveal the original text. In the digital world, decryption also involves using the right key to unlock the encrypted data. Without the correct key, the data remains encrypted and unreadable, like a locked diary without the key. Let's talk about keys for a moment, shall we? They're the unsung heroes of cryptography, the tiny but mighty tools that make encryption and decryption possible. In cryptography, keys are pieces of information that determine how the encryption and decryption algorithms work. The strength of your encryption depends heavily on the strength of your keys. A weak key is like using a flimsy padlock on your diary. Anyone with a bobby pin could pick it open. A strong key, on the other hand, is like having a bank vault protecting your secrets. Virtually impenetrable. We'll dive deeper into each type in the following sections. Section 5, Symmetric Key Cryptography. One key for both. Let's talk about symmetric key cryptography, shall we? It's like having one key that can both lock and unlock a door. In this type of cryptography, the sender and receiver use the same key to encrypt and decrypt the message. Think back to our postcard example. You and your grandma both knew the secret code, the key, allowing you to encrypt the message and her to decrypt it. This method is pretty straightforward and efficient, especially for encrypting large amounts of data. However, there's a slight catch. The biggest challenge with symmetric key cryptography is securely sharing the key. Despite this challenge, symmetric key cryptography is still widely used today, often in combination with other methods to ensure secure key exchange. Section 6. Asymmetric Key Cryptography, 2 keys for extra safety. Now let's move on to asymmetric key cryptography, a slightly more complex but incredibly secure method. This method is fundamental in ensuring the confidentiality and integrity of our digital communications. Imagine having 2 keys, one that can lock the door but not unlock it, public key, and another that can unlock it but not lock it, private key. This analogy helps us understand the basic principle behind asymmetric key cryptography. In this system, each user has 2 keys, a public key that they can share with anyone, and a private key that they keep secret. The public key is like a mailbox that anyone can drop a letter into, but only the owner can open. The public key can be used to encrypt messages, but only the corresponding private key can decrypt them. This ensures that even if someone intercepts the message, they cannot read it without the private key. Let's say you want to send a secret message to your friend. You would first need their public key. You would encrypt the message using their public key, which they have shared with you. This way, the message is secure during transmission. Once encrypted, only your friend can decrypt the message using their private key, which they keep safe and sound. This process ensures that the message remains confidential. Asymmetric key cryptography is incredibly secure because the private key, which is essential for decryption, is never shared. This makes it nearly impossible for unauthorized parties to access the encrypted information. This method is widely used for secure communication online, such as sending emails, online banking, and making online purchases. It provides a robust layer of security that protects sensitive information from prying eyes. Section 7. Hashing, making sure your message wasn't tampered with. So far, we've talked about encrypting messages to keep them secret, ensuring that only the intended recipient can read them. But what about ensuring that the message hasn't been tampered with during transmission? How can we be certain that the content remains unchanged? That's where hashing comes in, a cryptographic technique that's like a digital fingerprint for your data, ensuring its integrity. Imagine you're sending a super important document to your boss, something that must remain exactly as you wrote it. You want to make sure that nobody changes even a single comma in the document, preserving its original form. Hashing can help with that. It acts as a safeguard against any unauthorized changes. A hash function takes your document and creates a unique hash value, a string of characters that represents the data in a unique way. Even a tiny change in the document, like adding a space or changing a comma, will result in a completely different hash value, making tampering evident. So you send the document and its hash value to your boss, ensuring they have both the content and its digital fingerprint. They can then run the document through the same hash function and compare the resulting hash value with the one you provided, verifying its integrity. Hashing is widely used in data storage and digital signatures to ensure data integrity, making it a crucial tool in the digital age. Section 8. Real-life examples of cryptography in action. Okay, enough with the technical jargon. Let's break it down into something more relatable. Let's look at some real-life examples of how cryptography is used every day to protect your digital life. You might be surprised at how often you rely on it. Remember those online banking apps you use to transfer money and pay bills? Cryptography ensures that your transactions are secure. Cryptography is working behind the scenes to protect your financial information from being intercepted by cybercriminals. It's like having a digital bodyguard. When you send an email, especially one containing sensitive information, you want to make sure it reaches the intended recipient without anyone snooping. Email encryption protocols like TLS/SSL use cryptography to secure your emails in transit, making it much harder for hackers to intercept and read them. It's like sealing your letter in a tamper-proof envelope. Ever use public Wi-Fi at a coffee shop or airport? It's convenient but comes with risks. While convenient, these networks can be risky as hackers can potentially snoop on your online activity. It's like having someone eavesdrop on your conversation. VPNs use cryptography to create a secure tunnel for your internet traffic, protecting your data from prying eyes. Think of it as a private, secure pathway through the internet. Remember those strong passwords you're supposed to create for all your online accounts? They are your first line of defense. When you create a password, websites and apps use hashing to store a secure version of it on their servers. This process scrambles your password into a unique string of characters. This ensures that even if a hacker gains access to the database, they won't be able to see your actual password. It's like turning your password into a secret code. These are just a few examples of how cryptography is silently working in the background to protect your digital life. It's an invisible shield that keeps your information safe. Section 9. Cryptography and how it protects your digital life. You might be thinking, okay, cryptography sounds important, but how does it actually affect me? Well, my friend, it affects you more than you might realize. In today's digital age, our lives are increasingly intertwined with the internet. We shop online, bank online, communicate online, and even date online. All of these activities involve transmitting sensitive information over the vast and often treacherous landscape of the internet. Without cryptography, all of this information would be vulnerable to interception and theft by cybercriminals. Cryptography acts as a digital guardian, protecting your sensitive information from unauthorized access and ensuring that your online activities remain private and secure. Section 10. The future of cryptography, staying ahead of the bad guys. As technology continues to evolve at a rapid pace, so too do the methods used by cybercriminals to try and steal your data. One of the most exciting developments in cryptography is the rise of quantum computing. While still in its early stages, quantum computing has the potential to revolutionize many fields, including cryptography. Quantum computers are incredibly powerful and could potentially break many of the encryption methods we rely on today. However, fear not. Cryptographers are already hard at work developing new cryptographic algorithms that are resistant to attacks from even the most powerful quantum computers. The future of cryptography is full of challenges and opportunities. As technology advances, we can expect to see even more innovative and sophisticated methods of protecting our data. Section 11. Conclusion: cryptography, the unsung hero of the digital age. So, there you have it, folks. Cryptography may sound like a complex and intimidating topic, but it's an essential part of our digital lives. It's the unsung hero working tirelessly behind the scenes to protect our privacy, secure our communications, and keep our online experiences safe from harm. From online banking and email security to password protection and virtual private networks, cryptography is everywhere, silently safeguarding our data and ensuring that we can navigate the digital world with confidence. So, the next time you're online, take a moment to appreciate the silent guardian of the digital age: cryptography.